Hello everyone, this is Teacher Kathy, and today we're going to discuss the solution to some of the exercises on logarithmic and exponential functions. So here are 15 numbers, but we're going to solve only the first 8 numbers in this video presentation. Also, we're going to solve the other one, which is on word problem, on another set of presentation. So the first one here is to solve the following equation. 6 raised to the 2x equals 3. We take the logarithm of both sides and come up with the following. The logarithm of 6 to the 2x equals the logarithm of 3. And then by the property of logarithm, we can actually take this exponent here and place it here. So we will have 2x, the logarithm of 6 equals the logarithm of 3. And then solving for the value of 2x, at this point, we can divide both sides by logarithm of 6. But since we are interested with x, we can again divide log of 3 with 2. So x now equals the logarithm of 3 all over 2 times the logarithm of 6. For the second example, we have 2 to the 3x minus 1 equals 16 to the 2x plus 3. So again, just like what we did earlier, we take the logarithm of both sides. So we now have the logarithm of 2 to the 3x minus 1 equals the logarithm of 2x plus 3. And then by the properties of logarithm, we can take again this exponent here and place it here, multiply with log of 2. Similarly, this one. So we have the following. That is, the quantity 3x minus 1 times the logarithm of 2 equals 2x plus 3 times the logarithm of 16. And then we can distribute 3x minus 1. So first, we have 3x times log of 2 minus log of 2 here. And we can also distribute 2x plus 3 to log of 16. So we have the following. That is one. 3x log of 2 minus log of 2 equals 2x log of 16 plus 3 log of 16. Again, we have to simplify by combining 3x log 2 with 2x log 16. So we put it on one side here, 3x log of 2 minus 2x log of 16. And then we have on the other side 3 log of 2, what is left here? So you have 3 log of 2, and then transposing this, so you now have plus log of 2. We can simplify 3x log of 2 minus 2x log of 16 by factoring out x. So I have the following. X, 3 log of 2 minus 2 log of 16 equals 3 log of 16 plus log of 2. Solving for x, we can divide both sides by this quantity, 3 log of 2 minus 2 log of 16. So dividing that by 3 log of 2 minus 2 log of 16 to get the value of x. So x now is 3 log of 16 plus log of 2 all over 3 log of 2 minus 2 log of 16. Now, computing for log of 16, we have 1.2, and log of 2 is 0.301. So, plugging in the value of log of 2 here, 0.301, and the value of log of 16, which is 1.2, and then combining values here, 3 times 1.1 plus 0.301 all over 3 times 0.301 minus 2 times 1.2 will give us the value 3.901 all over negative 1.497. Meaning to say, if we solve for this one, we get the value negative 2.6. As for the third example, notice that the base here is 2. And we have x times x minus 1. So logarithm of x times x minus 1 to the base 2 equals 1. If you remember, the definition of a logarithm of a number is the exponent to which the base is raised to get that number. So in order to get x times x minus 1, here, you have to raise the base 2 to this exponent 1. So we now have the logarithm of x times x minus 1 equals 1 can be rewritten as 2, which is the base, raised to the 1, which is the exponent, times x, is equal to x times x minus 1. So simplifying this further, we have 2 equals, you can multiply this one, so you have x squared minus x. And then this one is an equation which can be rewritten as x squared minus x minus 2 equals 0. And we can solve for this one. To factor, we have x minus 2 times x plus 1. Why? Because by factoring, this will give us x squared. And when we multiply, this will give us x squared. This is minus 2x, and this is plus x. So the middle term is negative x. Meaning to say, we have 0 equals x minus 2, 0 equals x plus 1, and solving for x, we have x equals 2, we have x equals negative 1. Number 4, 2 to the x plus 2 to the negative x equals 6. Now, we can rewrite 2 to the negative x as 1 over 2 to the x. So we have the following. 2 to the x plus 1 over 2 to the x. Because this is a negative exponent, and you can rewrite this as 1 over 2 to the x equals 6. We can take this as our LCD and come up with 2 to the x as our LCD. And then we have 2 to the x here. So you have 2 to the x times 2 to the x will give us, the exponent is x plus x. So you have 2x plus 1. And then we can multiply both sides by 2 to the x so that we can get rid of the fraction. So multiplying both sides by 2 to the x will give us the following. 2 to the 2x plus 1 equals, because we multiply this by 2 to the x, we have 2 to the x times 6. And then we can transpose 2 to the x times 6 on the other side, and then plus 1 equals 0. But when you transpose that, that becomes negative. So we have the following. 2 to the 2x minus 2 to the x plus times 6 plus 1 equal to 0. Notice that we have 2 to the x here, and we also have 2 to the 2x here. So that your 2 to the 2x can be rewritten as 2 to the x quantity squared minus 6. Again, you can put 6 on in front here. Minus 6, 2 to the x plus 1 equals 0. We can let 2 to the x to be equal to u. So that from here, if you have u equals 2 to the x, you can have the following, that is u squared minus 6u plus 1 equal to 0. So we're going to solve for this one. because we cannot factor at this point, then we make use of your quadratic formula. So A here is equal to 1, B is negative 6, and C here is equal to 1. You remember your quadratic formula? Your quadratic formula says you have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. But in this case, because we have a quantity u, then we can rewrite this as u equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we now can replace the values here. So this is negative 6, but this is negative b, so that becomes positive 6 there. So we have positive 6 plus or minus. This is b squared again. So when you square that one, the negative value, it becomes positive 36. Minus 4 times 1 times 1 all over 2 times 1. Solving for the value, we have the following, that is 6 plus or minus, this becomes square root of 32 all over 2. So if we solve for square root of 32, we come up with 5.656854. Adding it with 6, or in another case, subtracting it with the value of 6, we'll have the following, that is 11.656854 over 2, and then other value for u, when you subtract, will be 0.343146. So this value will give us 5.8244, and this value will give us 0.17153. But remember that you are not solving for u, you are solving for x. So we have to do the following this time. That is u equals 2 to the x. So solving for x, we have to substitute the value of u that we get. That is 5.824 equals 2 to the x. And we have earlier 0.17153 equals 2 to the x. Applying again the logarithm on both sides, we will have the logarithm of 5.824 equals, this is the logarithm of 2 to the x, but that can be rewritten as x log of 2. Similarly, we can solve later on this part. So solving for x here, we have divide both sides by the log of 2. So log of 5.824 divided by log of 2, and this one x log of 2 divided by log of 2. Now half x is the logarithm of 5.824 over log of 2. And solving for the log of 5.824, we get 0.7652221, and the log of 2 is 0.30103. Meaning to say, when we simplify that, we get x equals 2.54. On the other hand, if we try to solve the logarithm of 0.17153 and the logarithm of 2 to the x, we come up with the following. The logarithm of 0.17153 equals x times the logarithm of 2. So again, what do we do here to solve for x? We try to divide both sides by logarithm of 2. So we come up with the logarithm of 0.17153 over log of 2. And solving further, we now have the following. Logarithm of 0.17153 on your calculator will give you 0.7656599, and the logarithm of 2 again is 0.30103. So you can try to verify these values later on with your calculator. So x now is equal to the negative of 2.54. So the value for the logarithm of 0.17153 is Take note, it's